in the calculus playlist, we came up with a rationale for Euler's formula. Euler's formula. And I guess that video has gotten somewhat famous with me talking about minds being blown and people not having emotion. But just as a reminder, Euler's formula is that e to the I theta, and it is just the formula by itself is pretty amazing, but it becomes especially amazing when you substitute substitute pi or tau for theta. And if you don't know what tau is, there are videos on that. But Euler's formula tells us that e to the I theta, there's a very good rationale for saying that this is going to be equal to cosine of theta plus, and I'll just change the colors for fun, plus I sine of theta. And so one thing I want to do is explore this a little bit. Can I express, because of Euler's formula, can I now express cosine of theta in terms of some combination of the other stuff? And can I now express sine of theta in terms of some other combination of the other stuff? Well, let's think about how we can isolate a cosine theta. If this is e to the I theta, let's see what e to the negative I theta it would be. Negative I theta. This would be equal to, let me do it over here. Let me do it over here on the right-hand side. So e to the negative I theta, this is the same thing as e to the I times negative theta, which would be equal to, by Euler's formula, it would be equal to cosine of negative theta plus I sine of negative theta. Plus I sine of negative theta. Well, cosine of negative theta, this is the same thing as cosine of theta. That's the same thing as cosine of theta. And sine of negative theta is the same thing as negative sine of theta. So this whole thing simplifies to negative I sine of theta. So we can write e to the negative I theta. We can write e, let me do that pink color. We can write e to the negative I theta as being equal to cosine of theta minus I sine of theta. Minus I sine of theta. And now this is something, we have something pretty interesting going on. If we add these two expressions, these two equalities right over here, the left-hand side, so let's just add them up. The left-hand side, we're going to be left with e to the I theta plus e to the negative I theta. And on the right-hand side, these I sine thetas are going to cancel out with each other. The I sine theta is going to cancel out, and we're going to be left with 2 times cosine of theta. 2 cosine theta. And so now it's pretty straightforward to just isolate the cosine theta. Divide both sides by 2. Divide both sides by 2, and we get something pretty interesting. We get that cosine of theta is equal to this business. E to the I theta plus e to the negative I theta, all of that over 2. And we could do a similar type of thing to try to isolate. Let me rewrite it over. So let me rewrite it, this little discovery we made. Cosine of theta can be rewritten as e to the I theta plus e to the negative I theta, all of that over 2. So that's kind of interesting. We can now express cosine of theta in terms of a bunch of exponentials right over here. Let's see if we can do the same thing for sine of theta. So sine of theta, let's imagine e to the I theta. And let's try to do the other, there's always these weird kind of parallels between cosine and sine. So let's just see what happens if we were to subtract this from that. So let's try doing that. If we were to take e to the I theta, let me just rewrite it over again. E to the I theta is equal to cosine of theta plus I sine of theta plus I sine of theta. And from that, let's subtract e to the negative I theta. Well, now we're going to subtract this, so we're going to get negative cosine theta, and then we're subtracting this, so plus I sine theta. So plus I sine theta. And so we are left with, when we do the subtraction, the left-hand side, we have e to the I theta minus e to the negative I theta, minus e to the negative I theta is equal to, this cancels out, and we're left with 2I sine theta. 2I times sine theta. If we want to solve for sine theta, we divide both sides by 2I. divide both sides by 2I, and we are going to be left with sine theta is equal to this business right over here. So let's do this. So sine theta, so this is our other discovery. Sine theta can be written as e to the I theta minus e to the negative I theta, all of that over 2I. So there's something interesting about these structures. I can write cosine of theta as the sum of these two exponentials that are dealing with imaginary numbers, sine of theta as the difference of these two exponential numbers dealing with imaginary numbers. Actually, over here, it's actually the average of the two functions. You're dividing by 2. Here, we're dividing by 2I. And if you don't like that I in the denominator, you can multiply the numerator and the denominator by I. This will become a negative. You'll have the I in the numerator. But either way, you will have the same expression. So this is all I can say about this is this is just kind of interesting. It's just kind of a fun exploration of mathematics. But maybe there's something neat about the structure of these functions. What happens if we were to take functions like this, but if we were to essentially get rid of the i's right over here? They seem like there might be some kind of an analog between cosine of theta and sine of theta. And so let's define those functions. And in the next few videos, we'll explore them and see if they really are analogous in some bizarre, strange, and beautiful way to cosine of theta and sine theta. So we're just going to make new function definitions, and they're just being inspired by these new ways that we discovered to write cosine of theta and sine theta. And I'm going to call the first function, I'm going to call it cosh. And it really does come from hyperbolic cosine. And we'll explore more why we call it hyperbolic cosine. But let's just call it cosh. I'm just experimenting right over here. And we'll just say cosh of, let's say cosh of x is equal to, it's going to be all of this. It's going to be inspired by this, but we're going to get rid of all of the i's. So it's going to be e to the x plus e to the negative x, all of that over 2. Once again, just inspired by this right over here, getting rid of all of the i's. And then let's define another one, hyperbolic sine. So I'll call it sinh for hyperbolic sine, I guess you could also do, of x. And I'm just going to get rid of all of the i's. I'm just being inspired by this. So e to the x minus e to the negative x, all of that over 2. And in the next few videos, we're going to start exploring this. We're going to start realizing that there is this strange, bizarre parallel between these things and trigonometric and our traditional trigonometric functions. Now, these will show up in some of your mathematics, but it is important. These aren't as core, especially in traditional mathematics, as these two characters are here, but it is a fun exploration.